Here we go. Okay, number 4 off of the related rates homework says, a water tank has the shape of an inverted circular cone with a base radius of 2 and a height of 4. If water is being pumped into the tank at a rate of 2 cubic feet per minute, find the rate at which the water level is rising when the water is 3 feet deep. Now, I'm actually going to do this problem differently than the way I did it on the notes, because I think that more people understand the second way than the way that I did it on there. So let me show it to you. Draw the inverted cone. Inverted as in I want it on its tip, not on its circle. Okay? So for number 4, I'm going to draw my cone. Because, that's, to me, that's the way a cone should look, because that's the way it holds ice cream. But that's actually not the geometric way a cone should look. It should look sitting on its base. This is considered inverted. And some people were having problems with that when they were doing it. Label the radius and the height. These values are constant. So the radius I can go ahead and label 2, and the height I can go ahead and label 4, because they are never changing. Okay, part B. Draw a water level in the cone. Since the water level will be changing, label the radius and the height of the water with R and H. So here's the cone height of water. It's a little hard to draw because it's kind of crowded in here. Should have drawn it a little bit bigger. The height of the water is H. The radius of the water is R. Okay? Because they are changing. Now, answer me this question. As you fill this with water, will the height change fastest at the beginning or the end? The height will change fastest at the beginning, agreed? Because there's less space for it to go into, and eventually it'll slow down. So we're trying to find the height, the rate for the height, when it's 3 meters deep. Okay? So, part C, what is the question asking you to find? Find the rate at which the water level is rising. So since it's asking me to find a rate, I know it's going to be something over dt. At which the water level is rising. Would that be dr or dh? That would be dh. And then the when that goes with it, the water is 3 meters deep. So when what is 3? H is 3. Okay? Have we used all the numbers in the problem? The 2 and the 4 went on the picture. The 2 meters cubed. Oh, I haven't written that down yet. So, So I need to know, what is this 2 meters cubed per minute? I know it's going to be a dt because it's a rate. What's measured in cubic units? Volume. So this is dV dt. Okay? Are you good with that? Okay, next. Write an equation relating the variables in part C. Now, an equation, but like I told you yesterday, they will give it to you on the AP exam. So volume equals 1/3 pi r squared h. That's the formula for the cone. All right. Now, instead of eliminating a variable, I'm going to do this a little bit differently than the way that the paper says. Okay? But I'm going to go ahead and keep going with this point. Do you see that I have 2 variables over here? 2 different variables. What rule do I have to use if I'm going to take the derivative? I'm going to have to use the product rule. Okay? So let's do that. So, what's the derivative of v? dv dt equals. The 1/3 pi is just going to sit there, and then I'm going to do product rule with the rest.
Why was the 1/3 pi?
Because it's a constant multiplied to a variable. Now, you could include it with the r squared if you wanted to when you take the derivative, but this way will work just as well. Okay. So, product rule is 1d2 plus 2d1, so 1 is r squared times d2. What do I write for d2? dh dt. Plus 2. What do I write for 2? Just h times d1. 2r dr dt. t. Okay, close parentheses. All right, now,
Wait, why'd you write just H?
because that was 2 times d1. Okay? Let me add that in. 1 d2, 2 d1. There we go. Okay, now, let's start plugging stuff in. What is dv dt? 2. Okay, that's nice and easy. Equals 1/3 pi parentheses. Okay, do I have r? Okay, is R2 on the water? No, so I can't use 2. Okay? I have dHdt, no, I'm looking for dHdt. I have H. I need R and drdt. So what I have to do is find a relationship between R and H so I can solve for R. Okay? Now, if I froze that water in there and I dumped it out, what shape would it be? It'd be another cone, wouldn't it? Would it be proportional to the... Yes. So, in reality, we have a cone and we have a little cone of water. Okay? So let me separate them and label everything. This is 2. This is 4. This is R. That is H. If they are proportional, can I relate R and H based on the way this picture looks? 2/4 equals R over H. That's the relationship you need. And that's going to help you find R, and it's also going to help you find drdt. So let's get R by itself. What's R going to be? I'm going to multiply both sides by H. So 1/2 H equals R. Okay? So if H is 3, what is R? 3/2 or 1.5. So 1.5 squared times dHdt, I don't know, plus H is 3 times 2R, and R is 1.5. Now, drdt. I don't know what drdt is, but I can find it with this equation. If I took the derivative of both sides of this, drdt would equal what? 1/2 dHdt. Do you agree with me? Y'all see what I just did? drdt is 1/2 dHdt. So right here I'm going to write 1/2 dHdt. Okay? All right, let's do some cleaning here. 2 equals 1/3 pi, parentheses. Need a calculator. 1.5 squared. Oops. It's 2.25 dHdt plus 3 times 2 times 1.5 times 1/2. So 3 times 2 times 1.5 times 0.5 equals 4.5. Do you see what I'm doing? Are you with me? They're both dHdt's, so I can add them together, can't I? So I have 1/3 pi, and that's going to be 6.75 dHdt equals 2. Let's just do some... Did I give the answer on the paper in terms of pi or not? No? Okay. So I can do 1/3 times pi times 6.75, and that's going to be 7.0685 dHdt equals 2. Now what? Divide by the 7. No. No, 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 no. 2 divided by second answer equals .283. That should be what's on the paper. Is that what it is? Okay. Now, the reason this was hard is because we had a variable that we didn't know its rate for. We had to come over here and find it. Now, doing it the other way, that the one that's on the paper, you can go study that and see if you like that better. You have to come up with this equation also, but you do it before you take the derivative instead of after. Okay, so the height is increasing because it's positive at a rate of 0.283. Now, since I didn't label it up here, I've got to label it for sure in here. What's it going to be? Meters per minute when the h is 3 meters. Okay. That's probably the hardest related rates problem you're going to do. Blah. Eventually, yes. 5 is not that hard. I'm telling you right now.